When someone approaches me with curiosity in their eyes and asks, "Professor Einstein, why does space curve around massive objects?" Or, "Why do magnets repel each other?" I see immediately that they believe they are asking a simple question. They expect a simple answer, perhaps an analogy to something familiar, a rubber sheet, a stretched fabric, something their hands have touched and their minds have already catalogued as understood. But I must disappoint them, and in doing so, perhaps I can teach them something far more valuable than the answer they seek. The question itself contains a fundamental misunderstanding about the nature of reality and our relationship to it. Let me explain what I mean, though I warn you this explanation may leave you more uncomfortable than when we began. That discomfort, however, is the price of genuine understanding, the illusion of depth. Imagine you are a child again, perhaps 5 years old, and you ask your mother, "Why is the sky blue?" She might tell you it is because of the way sunlight scatters in the atmosphere. Satisfied, you run off to play. But suppose you were a persistent child and you asked, "But why does light scatter that way?" Your mother, if she knew, might explain about wavelengths and molecules. Why do molecules scatter short wavelengths more than long ones? You press on. She describes the physics of particle interactions. But why do particles interact that way? Do you see what is happening? At each level, we are simply describing mechanisms, not providing ultimate explanations. We are pushing the mystery back one step, like moving furniture from one room to another and declaring the first room clean. The mess has not disappeared, we have merely relocated it. Eventually, inevitably, we arrive at statements like, "The electromagnetic force exists," or "Particles have these properties," or "The speed of light is constant." And here, finally, we must stop. Not because we are ignorant or lazy, but because we have reached bedrock, the fundamental postulates upon which our entire theoretical structure rests. These fundamental facts are not derived from anything more basic. They simply are. They are the grammar of the universe, the axioms from which everything else follows. To ask why they exist is like asking why logic is logical or why mathematics is true. The question dissolves into meaninglessness, the desert of familiarity. Now, why do people find this so deeply unsatisfying? I have thought about this question for many years, and I believe the answer lies in the architecture of human cognition itself. From the moment you were born, you began conducting experiments. You dropped objects and watched them fall. You pushed your toys and felt them push back. You learned that unsupported things descend, that solid objects resist penetration, that warmth flows from hot to cold. By the time you reached adulthood, you had performed millions of such experiments, and your nervous system had woven this data into a rich tapestry of intuition. This intuition serves you extraordinarily well in the middle world, the realm of objects roughly your own size, moving at speeds you can walk or run, existing in the temperature range where water is liquid. Your ancestors who had good intuitions about how rocks fly and where fruits fall survived and reproduced. Those with poor intuitions did not. You are the descendant of successful intuition builders, and you carry their hard-won wisdom in your neural architecture. But here is the profound limitation. Your intuition was built from a tiny, parochial sample of possible experiences. The universe is vastly larger and stranger than the African savanna, or the Roman Forum, or the medieval village. At very small scales, at very high speeds, at very low temperatures, at very strong gravitational fields, the universe behaves in ways that violate every expectation your intuition has carefully constructed. When you ask me to explain electromagnetic repulsion by comparing it to something you already understand, you are asking me to translate the true structure of reality into the language of your limited experience. But reality does not speak that language. Reality speaks in mathematics, in symmetries, in conservation laws, in field equations, and sometimes, often, there is no translation that preserves the meaning. The unity hidden in diversity. Let me approach this from a different angle, one that reveals something beautiful rather than merely frustrating. When you press your hand against this table, go ahead, do it now. You feel resistance. You call this solidity, and it seems perfectly ordinary, perfectly explainable. The table is solid after all. What could be more natural? But I tell you something remarkable. This solidity you feel is an illusion. Not in the sense that the table is not real, but in the sense that what you think is happening is not what is actually happening. Your hand is almost entirely empty space. If you could see with perfect precision, you would observe that the atomic nuclei in your hand occupy only about 1/1,000,000th of the volume. The rest, 99.9999% of what you call your hand, is void, inhabited only by the probability clouds of electrons. The table is the same, vast emptiness, with occasional motes of matter scattered through it like distant stars in the cosmic void. So when you press your hand against the table, you are pressing against emptiness. Why then does it not pass through? Why does the table resist? The answer is electromagnetic force. The electrons in your hand and the electrons in the table carry the same type of charge, and like charges repel. They repel across a distance, a very small distance, merely a few atomic diameters, but a distance nonetheless. Nothing ever truly touches anything else. What you experience as contact is actually repulsion, across a gap too small for your senses to detect. Now take two magnets, hold them with like poles facing each other. Feel that push, that invisible resistance. You can see the gap between them, a centimeter, perhaps an inch. You slide a piece of paper through the empty air, and still the magnets push apart. This feels mysterious to you. It feels like it requires special explanation. But here is the truth that should transform your understanding. The force you feel between the magnets is identical to the force you felt when pressing your hand against the table. Not similar, not analogous, identical. The same electromagnetic repulsion, operating by the same principles, described by the same equations. The only difference is scale. The gap is larger with magnets, large enough to see, large enough to make you uncomfortable because it violates your intuition about what force requires. But the physics is identical. Your discomfort is not detecting a real difference in nature. It is detecting a difference in your experience. You have pressed hands against tables 10,000 times, and your brain has learned to call this normal. You have pushed magnets apart perhaps 100 times, and your brain still calls this strange. But nature makes no such distinction. Nature knows only one electromagnetic force operating at all scales according to the same laws, the equations that bind reality. When I was younger, I believed that perhaps beneath the electromagnetic force, beneath gravity, beneath all the fundamental forces, there might lie some deeper unity, some more fundamental explanation. I spent decades searching for it, trying to unify gravity and electromagnetism into a single theoretical framework. I did not succeed, not in the way I had hoped, but the attempt taught me something crucial about the nature of physical understanding. The equations we write, Maxwell's equations for electromagnetism, my own field equations for gravity, are not merely human inventions imposed upon a plastic nature. They are constraints that reality imposes upon itself. The universe is mathematical in its very essence, and our equations are our best attempt to read the grammar in which natural law is written. When I write that the electromagnetic force between two charges falls off as the inverse square of distance, I am not creating this relationship. I am discovering it, reading it from the book of nature. And when someone asks me, but why does it fall off as inverse square rather than inverse cube? I can only answer, because that is what we measure. That is what the universe does. Could the universe have different laws? This is a question that has troubled philosophers for centuries, and I confess I do not know the answer. Perhaps in some abstract sense, different laws are conceivable, but the universe we inhabit has chosen these laws, and we must describe them as they are, not as we might wish them to be. The beauty of physics, and here I mean beauty in the deepest aesthetic sense, lies not in reducing everything to familiar mechanical analogies, but in discovering that wildly different phenomena obey the same underlying principles. Lightning and lodestones, chemical bonds and stellar fusion, the northern lights and the firing of neurons in your brain, all manifestations of electromagnetic interaction. This is unification, the highest achievement of scientific thought, recognizing that the apparent chaos and diversity of nature emerges from a small number of fundamental principles. The honest burden. I remember once giving a lecture where someone asked me about the photoelectric effect, the phenomenon that won me the Nobel Prize. They wanted to know why light sometimes behaves like a wave and sometimes like a particle. They wanted me to explain it by comparison to something familiar. I could have offered comfortable metaphors. I could have spoken of water waves that also carry discrete droplets, or of crowds that move both as collective entities and as individual people. Such analogies might have satisfied them momentarily. But I would have done them a disservice. I would have suggested that the quantum nature of light is less strange than it actually is, that it can be domesticated by classical thinking. The truth is more austere and more magnificent. Light is neither wave nor particle as classically conceived, but something for which our everyday language has no adequate words. It is what it is, and we must expand our conceptual repertoire to accommodate it. This is what I tried to convey in that famous interview about magnets, the one that made people angry because they thought I was being evasive or arrogant. I was being neither. I was being honest. The interviewer wanted me to explain magnetic repulsion by comparing it to something else, something familiar. But there is nothing more familiar than electromagnetism. It is the force responsible for everything you have ever touched, seen, or felt, save only gravity. To explain electromagnetism by comparing it to something else is to explain the foundation by reference to what it supports. It is circular reasoning disguised as explanation. Some accused me of failing to communicate, of hiding behind technical jargon, but I was doing the opposite. I was refusing to offer false comfort. I was insisting that if you want to understand fundamental reality, you must be prepared to accept that it does not match your preconceptions. You must be willing to rebuild your intuition from the ground up, using mathematics and experiment as your construction materials. This is difficult. It requires years of study, countless hours working through equations, solving problems, making predictions, and testing them against measurement. There is no shortcut. You cannot achieve genuine understanding through a 10-minute analogy any more than you can learn to play the violin by reading about it. But for those willing to undertake the journey, the reward is profound. After enough time working with the electromagnetic field equations, something shifts in your thinking. The mathematics stops being abstract symbols and starts being a language in which you can think directly about nature. The repulsion of magnets stops being mysterious and starts being inevitable, obvious, exactly what you would expect given the properties of charged particles and fields. You gain not just knowledge, but the power to predict, to calculate, to design technologies that harness these forces for human benefit. Electric motors, generators, transformers, radio transmitters, particle accelerators, all fruits of genuine understanding, not comfortable analogies. The courage to accept mystery. Let me tell you what I think is the deepest lesson here, the one that reaches beyond physics into philosophy, and perhaps even into how we should live. The universe does not owe you an explanation you can understand with your current cognitive toolkit. It does not owe you comfort or familiarity. It is what it is, operating according to principles that may seem strange or even impossible to your intuition. You have two choices when confronted with this reality. The first choice is to reject it, to insist that anything genuinely true must be reducible to something you already understand, to demand that nature conform to your expectations. This path leads to frustration and ultimately to ignorance. You will forever be seeking explanations that do not exist, rejecting accurate descriptions as not really explaining anything, missing the profound beauty of what we have discovered because it does not match the shape of what you expected to find. The second choice is humility, recognizing that your intuitions, while valuable, are limited products of your limited experience. Accepting that genuine understanding sometimes requires you to rewire your thinking, to build new intuitions based on mathematical truth rather than everyday experience. This path is difficult, but it leads to something far more valuable than comfortable ignorance. It leads to genuine contact with reality as it actually is. I have spent my life taking the second path. When I realized that simultaneity was relative, that time itself could stretch and compress depending on motion and gravity. Every fiber of my intuition screamed that this was impossible. But the mathematics was clear, and the experiments confirmed it. So I accepted that my intuition was wrong and rebuilt it, slowly and painfully, around the new truth. This is what science demands of us: the courage to accept that we might be wrong, that the universe might be stranger than we imagined, that understanding might require us to abandon cherished beliefs and comfortable frameworks. The magnificence of what is. So I return to where we began, Those magnets pushing apart in your hands, that invisible force acting across empty space. You wanted me to explain it by reducing it to something simpler. I have told you this cannot be done. The electromagnetic force is fundamental. There is nothing beneath it, nothing more basic to which we can reduce it. But I offer you something better than reduction. I offer you unification. That force you feel? It is the same force that holds atoms together and keeps them apart. The same force that allows chemical reactions, that powers every living cell in your body, that carries signals through your nervous system, that makes light possible, that allows stars to shine, that created the chemical elements from which you are made. You are not separate from this force, you are a manifestation of it. Every sensation you have ever felt, every thought you have ever had, every motion you have ever made, all of these are elaborate dances of electromagnetic interaction. The fundamental forces of nature are not exotic phenomena occurring in special laboratory conditions. They are the fabric of everyday existence, usually hidden by our limited perception, but revealed through careful observation and mathematical analysis. This is what should inspire awe, not that we cannot reduce magnets to something simpler, but that we have discovered the deep unity underlying all of material existence. We have found that the apparent complexity and diversity of nature emerges from a remarkably small set of mathematical principles. The electromagnetic force, gravity, the nuclear forces. These are the brushstrokes with which the universe paints itself into existence. And we, through physics, have learned to read the signature of the artist. The real answer. So let me give you the answer to your question about magnets. The real answer that you were not quite asking for, but that I believe you need. Magnets repel because they have magnetic dipole moments, quantum mechanical properties, arising from the spin and orbital motion of electrons. When these dipoles align, they create magnetic fields that store potential energy. Systems naturally evolve toward lower energy states. Two north poles facing each other represent high potential energy. Pushing them apart lowers the energy, releasing it as kinetic energy of the magnets moving away from each other. That is the answer. That is as deep as the explanation goes. You can ask deeper questions. Why do electrons have spin? I can point to the Dirac equation unifying quantum mechanics with special relativity. Why does the Dirac equation hold? Because it accurately describes what we measure. Why does nature follow these patterns? Here the chain of causation ends. We have reached bedrock. The predictive power of this understanding is immense. I can calculate the magnetic force between two dipoles to extraordinary precision. I can design devices that manipulate magnetic fields to trap particles, focus beams, store information, generate electricity. This is real understanding. Not philosophical satisfaction, not comfortable analogy, but the ability to predict and control natural phenomena. Is this answer satisfying? Perhaps not to everyone. Some will always crave a deeper why, will always feel that true understanding must reduce the unfamiliar to the familiar. But I tell you frankly, this craving is itself the obstacle to understanding. It assumes that reality must match the patterns your brain learned in childhood, that the universe must be comprehensible in terms you already understand. Reality makes no such promise, but it offers something better. The invitation to expand your understanding, to build new intuitions, to see the world not as it appears to your parochial experience, but as it actually is in its magnificent mathematical totality. The magnets in your hands are not mysterious objects requiring special explanation. They are ordinary manifestations of the fundamental forces that structure all of existence. The mystery is not in them, but in your perception, the gap between your intuitive expectations and the actual operation of nature. Close that gap, and you do not solve the mystery. You dissolve it. You realize there was never a mystery at all, only a misunderstanding about what kind of explanation is possible or necessary. That is the gift physics offers. Not comfortable answers, but uncomfortable truths that, once accepted, reveal a universe more elegant, more unified, and more comprehensible than our untutored intuitions could have imagined. The magnets push apart because that is what electromagnetic fields do when configured in this particular way. And electromagnetic fields behave as they do because that is the fundamental structure of reality, and that is not a failure to explain. That is what explanation looks like when you reach the foundation. This is the truth I tried to convey in that interview decades ago. Some heard arrogance. I intended only honesty. The universe does not owe you familiar analogies, but it offers you something far more valuable, its actual nature written in the language of mathematics, waiting for those brave enough to learn to read it.